This video is going to be solving differential equations to a real problem, a modeling problem. So we're given that dH dt, which is the rate of growth of a tree or a shrub, and the growth rate during the 6 years could be modeled by this function that they give us, 1.5t plus 5. And so we're supposed to find the general height at any given time. So we're going to find h. And we're given that the height is 12 centimeters tall when they're planted. So h of 0 equals 12. So the first step is to integrate both sides with respect to time. Integral of dH dt, it's like multiplying both sides by dt. And so the dt's, if you think about it in your head that way, they kind of cancel out. Integral of dH with respect to time, dH dt with respect to time is just h. Integral of 1.5t is 1.5 t squared divided by 2. You always divide by the power you raise it to, plus 5t plus a constant. We always have our constant of integration. So 1.5, we're going to get fractions here, so you can either change this to a decimal or you can say 1.5 is 3 halves. So 3 halves times 1 half is 3/4. So you can write it as 0.75 if you want. So now we don't have our height equation yet because we need to find c, so that's when we plug in our point. When t is 0, c is 12. So we have 0 plus c, plus c equals 12. So the height is 3/4 t squared plus 5t plus equals 12. Now you can answer the question, after 2 years we got that. How tall are the shrubs when they sold? Well, they're sold after 6 years, so all we're doing is finding h of 6. So 3/4 times 6 squared plus 5 times 6 plus 12. 36 times 3/4 is 27. Plus 30 plus 12. So 57 plus 12 is 69. Centimeters. Get that back from the problem. The second problem here is a population growth problem, and we get a growth rate of the population. dp dt is proportional to the square root of t, where p is the population. So we have this time that's 0 to 10 if you can't see it, and they give this to you as k radical t. The initial size of the population is 500, so p of 0 is 500. So we started with 500, and after 1 day the population has grown to 600. Estimate the population after 7 days. So what we need to do is figure out the equation for the population function so we can plug in 7. So we're going to start out by integrating. This side's the easy side, that's P. Now remember, a constant is always along for the ride, so this is really kt to the 1/2. Raise it by 1, that would be kt to the 3/2 divided by 3/2 plus c. And so this really ends up being P equals 2/3 k t to the 3/2 plus c. Now, when we plug in our population, it has to work to find c. It has to work for both of these points. So let's go ahead and plug in 1. When we plug in 1 or plug in 0, when we plug in 0, we get P equals 2/3 k times 0 plus c, and P is 600. Sorry. Sorry, C is 500. So we have P equals 2/3 k t to the 3/2 plus 500. And there's a reason why they gave us a second point. That's so we can find k. So we plug in again. 600 equals 2/3 times k. 1 to the 3/2 is just 1 plus 500. So if you subtract 500, then you can find k. So k is 3/2 times 100, which is 150. So we have everything now to rewrite our equation. Our equation is now P equals 2/3 times 150, that's k, t to the 3/2 plus 500. So P, simplifying, you can multiply 2/3 times 150 and you get 100. And it says estimate the population after 7 days. So we're finding P of 7. 100, 7 to the 3/2 plus 500. I'm going to erase a little bit here so I can get some room. Now 7 to the 3/2 means you take 7 to the 3rd power. So that's 49 times